Okay, so let's begin with what is a rational expression here before we look at how to simplify or reduce them. A rational expression is a ratio means fraction, of polynomials. Okay, so they're just a rational expression is just a fraction, but now your numerator and denominator may be polynomials. Okay, so here's the very important thing. A key just of algebra in general, a key aspect of algebra is that we perform the opposite of an operation to undo another operation. For example, addition and subtraction undo each other. Multiplication and division undo each other. And we can keep going on. Squaring and square rooting undo each other, etc., etc. Okay? So here's the key. So since a rational expression is a fraction, it is division. The fraction bar means division. Okay? To undo division, we need multiplication. This is the key to this entire video here. Okay? To undo division, we need multiplication. So we will be creating multiplication before we cancel. That's the idea here. All right? Okay, so let's take a look at some examples of this, and hopefully this will be clear. So here's a problem that we will simplify. Simplifying a rational expression means reduce to lowest terms. That's all it means. You're just reducing the fraction. Okay? So, and in order to do that, as I just mentioned, we need to create multiplication. So how do we create multiplication? We create multiplication by factoring. Factoring gives us a product, a multiplication. All right, so here's the first example that we'll do. Let's say we want to simplify x minus 3 times x plus 5 over x plus 5 times x plus 4. We're just trying to reduce this. Well, the fraction bar here is division. The top, on the surface, the top is multiplication. And on the bottom, this on the surface, you have two things multiplied again, so this is multiplication. You don't dig any deeper, you just look on the surface. So since we have multiplication and division, we know these things will undo each other, and so what that tells us is that any common factor on the top will cancel with the same common factor on the bottom. So in this case, x plus 5 divided by x plus 5 is 1. So we cancel those and replace them with 1's. And we end up with a new rational expression that says we have x minus 3 times 1, which is x minus 3, over 1 times x plus 4, which is just x plus 4. Now, this is still division, but the top on the surface is subtraction. And on the bottom, we have addition. This means no canceling, because we don't have multiplication mixed with division. Okay? It would have to be all multiplication on top and all multiplication on bottom in order for us to cancel. A lot of people try to cancel the x's here, but they're part of subtractions and additions, which are not the opposite of division. Okay? So we cannot cancel any further in that example, and so we have reduced this fraction completely to its lowest terms. We've simplified the rational expression. Okay? Now in this example, the original problem was already factored. That's why it was multiplication already, and we could just go ahead and cancel. But let's see how to handle a problem that is not factored, that's not already multiplication, and see if we can reduce it. So here we have a rational expression, we have division, and in order to cancel things on top with things on bottom, we need multiplication on the top and the bottom. But on the surface on top, we have subtraction. So right away, we know we can't cancel. The bottom is addition, that's irrelevant. We know we can't cancel already because the top is not multiplication. Okay? So what we need to do is turn the top and the bottom into multiplication. The way to do that is to factor. So how do you factor the top? Well, there's a common factor, a GCF, of 3x in both those terms. So we'll pull a 3x out, leaving x minus 2. And we'll factor the bottom. There is a common factor of 9x on bottom, which leaves y plus 2. And now we have division, of course, because of the fraction, and the top is multiplication. There's three things multiplied on the top. 3 times x minus 2. And on the bottom we have three things multiplied also. 9 times x times y plus 2. Those are all each called factors. The things that multiply together are called factors. So we have multiplication on the top and the bottom, so we know we can cancel any common factors. Well, x divided by x is 1, so those will cancel and leave behind 1's. 3 and 9 have a common factor of 3. 3 goes into 3 one time, 3 goes into 9 3 times. So what we have on top is 1 times x minus 2, which is just x minus 2. On the bottom we have 3 times 1, which is 3, times y plus 2. And you could leave your answer like this, or if you wanted to be technical about it and completely simplify it, you would get rid of the parentheses after you've done all your canceling and just distribute the 3 on the bottom to get 3y plus 6. So either of these are acceptable. This is actually better. This is actually more simplified, but this one over here is accepted because in this form, when it's factored, you can tell that nothing else cancels. So that's kind of nice, okay? So either one of those would be acceptable as a final answer to this problem. So here's another example that we will try to simplify or reduce. Again, we have division here, and on the top we have subtraction, and on the bottom we have three things added, so we have addition. Okay, so we can't cancel, so we need to create multiplication by factoring. Okay, well, if we factor the top, it's important to write this in descending order first. And let's actually go off to the side to do this work, okay? So let's do some side work over here for our factoring, just so we don't clutter this up too much. So 8 minus 2x squared, if I write in descending order, becomes negative 2x squared plus 8. And since my first term's negative, I'm going to factor a negative out. But I can factor a negative 2 out because 2 is a common factor. So I'll pull negative 2 out, which makes this x squared and makes this negative 4. It changes the sign when you factor out the negative. X squared minus 4 is a difference of squares, so it factors. I'm going to carry down my negative 2 and just have x plus 2 times x minus 2. So that's the top. 8 minus 2x squared is just this. So I can write that over here. Okay, let's work on x squared plus 5x plus 6. We're looking for two numbers that multiply to be 6 and add to be 5. Well, 2 and 3 work. So I'll split my middle term, 5x, to be positive 2x plus 3x. And then I'll factor by grouping. I'll group the first two and group the last two. Pull out an x of the first two, pull out a 3 of the second two, and then factor out the common x plus 2 to leave x plus 2 times x plus 3. And that's my denominator. Okay, now we have division, of course, and we have multiplication on top, and we have multiplication on bottom. Now we can cancel common factors. So x plus 2 divided by x plus 2 is 1, and nothing else cancels. So we will simply write our answer as negative 2 times 1 is negative 2 times x minus 2. On bottom we have 1 times x plus 3, which is just x plus 3, and that is completely reduced. No further factors cancel, so we are done. I almost forgot, I want to do a simple example so you don't get thrown off by these much easier problems. Let's say we have something like 15xy over 24x squared y. Well, we look at this and we have division, of course. The top is already multiplication and the bottom is already multiplication. There's no addition or subtraction anywhere whatsoever. It's already multiplication. On the top we have three things multiplied, 15, x and y, and on the bottom we have three things multiplied, 24, x squared, and y. So what we have is something that we can cancel with. 15 and 24 both share a factor of 3. 3 goes into 15 5 times, and 3 goes into 24 8 times. X squared is just x times x, which is multiplication. So one of those x's cancels with this x on top, leaving x to the first on bottom. And then y and y cancel, leaving 1's. So what we have as a result is 5 times 1 times 1, which is 5, over 8 times x times 1, which is 8 times x. And now that fraction, or rational expression, is completely simplified or reduced.